In this episode, we will learn about acid and base. The first thing we need to know is different definitions of acid and base. As a Arrhenius defines an acid as a substance that ionizes in water and produces hydrogen ions. For instance, HCl is an acid. He defined a base as a substance that ionizes in water and produces hydroxide ions. For instance, NaOH is a base. J.N. Bronsted and T.M. Lowry define an acid as a substance that is capable of donating a proton, which is the same as donating a hydrogen ion, and they define a base as a substance that is capable of accepting a proton. The species with a hydrogen ion is the acid, and the same species without the hydrogen ion is the base. The two species are called conjugate pair. Water can act either as an acid or base. Any substance which that ability is called amphoteric. Many of the concentration measurements in acid-base problems are given to us in terms of pH and pOH. When the number of hydrogen ions equal to hydroxide ion, the solution is neutral and pH equal to 7. When the number of hydrogen ions is greater than hydroxide ion, the solution is acidic and pH is less than 7. When the number of hydrogen ion is less than the number of hydroxide ion, the solution is basic and pH is greater than 7. It is important to remember that increasing pH means decreasing in number of hydrogen ions, which means that there are fewer hydrogen ions floating around, and the solution is less acidic. Alternatively, decreasing pH means increasing number of hydrogen ions, which means that there are more hydrogen ions floating around, and the solution is more acidic. Strong acids dissociate completely in water, so the reaction goes to completion and they never reach equilibrium with the conjugated bases. Because there is no equilibrium, there is no equilibrium constant, so there is no dissociation constant for strong acids or bases. Here are some important strong acids: HCl, HBr, HI, HNO3, HClO4, H2SO4, and important strong bases: LiOH, NaOH, KOH, BaOH2, SrOH2. Because the dissociation of strong acids goes to completion, there is no tendency for the reverse reaction to occur, which means that the conjugate base of strong acid must be extremely weak. It is much easier to find the pH of a strong acid solution than it is to find the pH of a weak acid solution. That's because the strong acid dissociate completely, so the final concentration of hydrogen ions will be the same as the initial concentration of the strong acid. When a weak acid is placed in water, A small fraction of its molecule will dissociate into hydrogen ions and conjugate basis ions. Most of the acid molecule will remain in solution as undissociated aqueous particles. In conclusion, today we learned about the definitions of acid and base and different strengths of acid and base.